So for this particular lab, let's go to page number. And this experiment is probably one of the easier experiments for the semester. It'll take you less than an hour if you're really efficient. Okay? So on a rainy day like today, maybe you need to go and take the rest of the afternoon off, but it'll be pretty fast. Just make sure that you answer the questions, the pre-lab, and the questions at the end. Okay? And the questions at the end are basically giving me the density and the results of your experiment. So this is what you guys are going to be doing in this particular experiment. You're going to be given 3 liquids, and the 3 liquids are found under that hood. Okay? What you guys are going to be doing is the following. First thing you want to do is, if you take a look at the directions on page 109, you need to measure the volume and the mass of an item in order to determine its density. Okay? The best way to do this is to take your graduated cylinder, your 10 mil graduated cylinder, and place it on the balance. Make sure that you tear the balance before you start, but place it on the balance. Then, if you have control of this balance, tear it so it reaches 0. Then when you add the water, remove it from the scale. That way you don't put water or the liquid on the scale. Add the liquid to the graduated cylinder. It tells you exactly how much volume to add. Okay? You could weigh it now, and that's the mass of the liquid. Okay, so if you tear it and you add your liquid, you can weigh it, and that's the mass of the liquid. And then, at the same time, you could now read the volume. So, in one procedure, you can get the mass and the volume. Calculate the density by taking the mass and dividing it by the volume, and then take that liquid and transfer it to a test tube. And then label that A. You go to your next substance. You got to make sure that your graduated cylinder is clean and dry, because if there's any residual liquid from the previous one there, it's going to ruin your result. So go to the sink and make sure it's clean and dry, and then take your graduated cylinder again, tear it, add your second liquid, read the mass, read the volume, calculate the density, and then put it into a second test tube. Okay? Procedure, like I said, goes pretty fast once you get a system down. Finally, you get to your last liquid. Clean your graduated cylinder again, put it on the scale, tear it, add your third liquid, measure the mass, measure the volume, and then you don't need to put this into any graduated cylinder. It's contained in itself. Calculate the density. Remember that the density is going to be the mass over the volume. So you've got 3 liquids here. So this is experiment 4. We have liquid A, liquid B, and liquid C. We've got the mass, we have the volume, and we have the density. So it's the mass over the volume. So you will be able to calculate the density for the 3 liquids before you move on to the next step. Let's say that liquid A has a density of 1.83. Let's say liquid B has a density of 0.92. And then liquid C has a density of 1.03. Okay? Let's just say that we have that. What you guys are going to be doing next is you're going to take all 3 liquids and you're going to put it in a common test tube. But you're going to pour it in a way so that they don't mix. Which liquid should I pour first? Should I pour the most dense liquid or the least dense liquid first? Which ones generally sink? The more dense or the less dense? So I would pour the more dense liquid first. Okay, so here I would pour liquid A first, and when you pour these things to a common test tube, what you want to do is you don't just want to dump it, because when you dump it, especially the second liquid, let's say I have two liquids here, okay? When I want to mix it, I want to make sure that this is at an incline, and then I want to take the liquid that I'm adding, and I want to pour it down the wall of the test tube so that it rolls down and it doesn't disturb the bottom layer. So I just want to roll it down, and if you do this right, you're going to get two layers. It's not going to mix, okay? Because we say that these liquids are immiscible. Immiscibles are when two liquids don't dissolve in each other. There's a terminology that you guys will answer in the Prelab, and there's miscible and immiscible. There's soluble and insoluble. And they're used for different things. When you say something is soluble, you mean that a solid dissolves in a liquid. Again, I remind you, it's a solid that dissolves in a liquid. When you say something is insoluble, then the solid does not dissolve in the liquid. When I say something is miscible, I say a liquid will dissolve in the liquid. Alcohol and water, for example, you mix those two, it dissolves in each other. When you say something is immiscible, then it's a liquid that doesn't dissolve in the other liquid. Okay? Something like vinegar and oil, or water and oil. They don't mix. So the miscible and immiscible is for a liquid and a liquid. Soluble and insoluble is for a solid and a liquid. You want to use those terms exclusively for those particular events. Okay? So right now we're looking at the miscibility of each liquid to each other. And so if you pour liquid A here, followed by which liquid? Which liquid should I pour next, according to my result? C. I would pour C next, that would be C, and then finally B. And then you want to label that. And then it's going to ask you in the procedure to sketch these things. Okay, which layers in the bottom and which layers on the top, A, B, or C. This may not be the right answer, so don't follow this. The next thing you want to do is you're going to take iodine. And the reason why you take iodine is because iodine is a chemical that has a certain property. Iodine is this chemical right here, I2. Okay? It's a solid material, it's a solid element. Don't get it in your fingers, it'll stain your fingers. Okay? But it's also used as an antiseptic because it can kill bacteria. If you put it in alcohol, tincture of iodine. It's something you can buy at the drugstore. But iodine is a solid, and what you know about iodine is that it's something, we like to say it's nonpolar. Chemicals that are nonpolar has its electron cloud evenly distributed over the entire compound. So the electron cloud for iodine is even, and so no one side or the other is more positive or more negative than the other. So we say it's nonpolar. When you guys hear the word polar, first thing that should come to mind is like the North Pole and South Pole. Like a magnet is polar because it's got charges at the extreme end. An atom that's polar is going to have charges, like HCl, at one side and opposite charges on the other side. One side of the molecule might be positive, the other side of the molecule might be negative. So we say that this is a polar situation. It's like a magnet. It's got a separation of charges. A chemical that's nonpolar has an even distribution of the charge. Now certain solvents are either polar or nonpolar. The molecules that make up these liquids will either be like a magnet or like a non-magnet. Since iodine is nonpolar, it will only dissolve in nonpolar solvents. So when you put iodine in here, and you just want to add about the size of a pea, okay, about that size right there of iodine, not a lot. When you put iodine in here, what you should see is that depending on which solvent is nonpolar, the iodine will dissolve. So you can tell me that, hey, liquid B is nonpolar. Or maybe two of these will dissolve the iodine. Liquid B and liquid A are nonpolar. Liquid C must be polar. So right there, this experiment will tell you the properties of these liquids relative to the property of iodine. And that's what you do in the next step. You add iodine, you pour it, and then you just watch where it dissolves in the three layer. The next thing you want to do is you're going to put a stopper here, okay? And be careful, because some of these liquids are volatile, and when you shake it, it goes into its gas phase, and it might cause a pressure buildup. And so some of these ports have been known to pop and splash on you, so be careful. Just take it, kind of shake it real quick, and then release the gas. Close it again, shake it real quick, and then release the gas. You're just mixing all of these up. Okay? And maybe all of them will combine and be miscible with each other, or maybe it'll stay separated. Or maybe you get two layers where two of them dissolves in each other and the third does not. So from that clue, you guys should be able to identify which layer is which. I might say this is layer B and A, and this is layer C. Okay? Depending on what the color of these layers are. So using the clues of the experiment, at the end you guys will be able to tell me which of these liquids are polar, which of these liquids are nonpolar, which of these liquids are miscible in each other, which of these liquids are immiscible to each other, which of these liquids is will iodine dissolve in, which of these liquids iodine will not dissolve in. And then you're done. That's the experiment. Okay? So at the end, you've got this post-lab question where you're given 3 items. The question itself is the following. Make sure I address that, because that's always a source of confusion. You have these 3 items, and they're solid items. And you add this to a bucket of water. You're going to calculate the density of these items, and then you're going to tell me which of these items will sink in this water, which of these items may float or has the same density as water, and which of these items will float, and which of these items will just hover. If it hovers in the interior of the water, it means that it has the same density as water. If it's floating on top of the water, it means it has a lower density than water. And if it sinks, it has a higher density than water. That's it. At the end of the class, you guys should turn this in, and that's the experiment. Pretty easy experiment, like I said. It goes pretty fast if you follow the directions.